Welcome into our maths class, and today we are going to continue with the Cartesian plane, but specifically we shall look at using rules, tables, and graphs to explore linear relationships. Now, we all know that when we have pronumerals, maybe two or so, they form a relationship. When they have a relationship, then there is a rule that connects the two pronumerals. Now, when we have such, the issue is how are these pronumerals related to each other? What relationship or what connection do they have, and how can they be shown? So, in most cases, we normally find that any situation that we have two unknowns forming something like an expression or an equation, then we say that it has been connected by a rule. For example, when you look at the relationship between degrees Celsius and degrees Fahrenheit, it is connected by the formula C, where C is for degrees Celsius, it is connected by this formula. Degrees Celsius is connected by C is equals to 5/9 into bracket F minus 32. Now this forms a rule, and when you work out here and find the various values of C and F, you'll always find that you'll form a straight line. So we normally say if we have such relationship between the pronumerals, and then when they are plotted they form a straight line, then we say that their relationship is linear. They have a linear relationship. It is not always true that all expressions that we have can form a linear equation, but some of them might be different. I want us to look at the following few examples of expressions and discuss in groups and see which one is which group. So take note that we are looking at the variables, an equation or expression formed by two or more variables. If these variables actually, when plotted, they form a straight line, then we say their relationship is linear relation. So we want to look at the following equations and see whether they can form linear or straight lines or not. Look at these questions, discuss in groups, and identify which one forms a straight line, which ones form curves. So, looking at it. So having looked at it, as we shall later on look at the plotting, you should have realized that only two form a linear equation, and we have one which forms a curve, that is y is equals to x squared. Now, how did we get that? That is with reference to what we learned earlier in our lessons, how we normally come up with linear equations to plot on a graph. So we can easily be able to identify this by doing the following. We want to fill this table, and filling this table we shall require. Now this y1 is for the first equation, y2 is for the second equation, y3 is for the third equation. Given that values of x are as seen 1, 2, and 3, what would be the values of y1? y1 would be 6 over x, and x is 1, which is 6 over what? 6 over 1, which is 6. If we look at when x is 2, then y1 would be 6 over 2, which is 3. When x is 3, then y1 would be 6 over 3, which gives us 2. What I'm having here, they form a pair of coordinates. And now these coordinates are the one which helps us to plot a graph. Now, if we are to plot this graph, it means you look at the behavior, because given this is the x-axis, this is the y-axis. Assuming we have roughly on the y-axis 1, 2, 3, 4, 5, 6, 7, and then x-axis we have about 4. 1, 2, 3, 4. Minus 1 this side. 1, 2, 3, 4. Just as gauge, you'll find that if we want to plot this, estimate is when x is 1, y is 6. When x is 1, y is 6. So this one will come to settle somewhere here. When x is 2, y is 3. So 2, 3 comes somewhere here. And when x is 3, when x is 3, y is 2. When x is 3, y is 2. So we find something like this. So you realize that when you join these dots, there will be a straight line. That is a straight line, and we say this line is y is equals to 6 over x. So we are looking at how best we can actually transfer the points on a table onto the graph. That is a graph, and this one here is a table. Take note of these values. We got when x was 1, then y is 6 over 1, which is 6. Then 6 over 2, which is 3. 6 over 3, which is 2. So these are the coordinates. For the third one here, when x, for the second one we have, when x is 1, y is x squared, which is also 1. When x here is 2, y is 2 squared, which is 4. And when x is 3, y is 2 squared, which is what? 9. Looking at that, the coordinates in our second equation is 1, 1, 2, 4, and 3, 9. If I am to estimate, 1, 1 will be somewhere here. Then 2, 4 will be somewhere here. We have it there. Then we are moving on to 3, 9. We are very keen. 3 is here, and 9 will be somewhere. It is 9 will be somewhere up. So you'll find that we are forming a curve. It is a curve. So the equation y is equals to x squared is a curve. It's not a straight line. That's why we said this one will be a curve. For the other one, the last one for y3, when it's x is 1 here, then y will be 2 times 1, which is 2 plus 1 gives us 3. Then 2 times 2, 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. So just to estimate 1, 3 is here. 2, 5. This is 2 and 5 will be somewhere here. And 3, 7, 3 is here, 7 somewhere here. So this one will form a straight line like that. So I'm only looking at it, sketching it. So this one is a straight line as well as this. Now, when we say they are straight line, then we are saying that x and y here, their relationship is linear. They have got what we call a linear relationship. Now, it is very important that before we work on this, we must know how to plot, which we covered in our previous lesson, that we must be able to draw a Cartesian plane with the x and y axes clearly labeled. Then the coordinates. From the equations, we generate the coordinates through the table. This table is simply to give us the coordinates. So for y1, for the first part, the coordinates were 1, 6, 2, 3, and 3, 2. That's what we are trying to look at. The second one is 1, 1, then 2, 4, then 3, 9. Those are coordinates. And the last one, the coordinate is 1, 3, 2, 5, and 3, 7. These are coordinates. These coordinates are the ones which are going to help us to plot our linear equations on a graph. So what do we need to know when dealing with the rules and tables while we are exploring what we call the linear relationship? We must have or know the following. We say a rule or a formula is an equation connecting two or more variables. Two or more variables. That gives us a rule or a formula. Another point that we must know is a straight line. If you happen to plot and you find that you have plotted a straight line on your graph, then we say in this straight line graph only result from a rule that is linear. So it results from a linear relationship. So for us to be able to graph a linear equation, or a linear relationship, to graph a linear relationship, using formula, we need to observe the following steps. We have several steps that we must observe. So we must observe these steps. We find that first we must construct a table. Now, and what is in this table? This table is going to be constructed, and we shall have the x values of x clearly indicated, so that we use the values of x to be substituted so that we can get the coordinates of y. So we must construct a table using the x coordinates. Then these x coordinates are substituted in to give us the y coordinates. The x coordinates are substituted in the linear equation to give us the y coordinates. So the moment we have the y coordinates, then we are able to identify both the x and y coordinates. Now, then if you are able to identify the y and x coordinates, so you highlight or you point out the x and y coordinates from the table, so that now you will be able to know what points are you going to plot. So the moment you have pointed out which coordinates you have, then you go ahead and start your plotting on a graph. So you plot the points. Remember, it is using the coordinates that you have been able to identify from the table. After that, join those points, you'll find that you will be drawing a line. You should draw a line through the points. So we need to observe these steps when we are constructing a linear equation. So generally, we must always observe the steps so that we can be able to know that this is a linear equation or it's not. This table will help us to identify such cases. So we want to look at a question on plotting a graph. So we have here the question, for the rule of y is equals to 2x minus 1, construct a table and draw a graph. Construct a table and draw a graph. Now, it is very important that we must follow the steps. And as I told you earlier, for us to be able to draw a table, to construct a table, we must assign values for the x coordinate. And then we substitute these values so that we can get the y coordinates. So I want us to construct a table where we have the x, and we shall give estimate values for x, and then we shall have y. Let us give it a range of -3 to +3. So when x is -3, -2, -1, 0, 1, 2, 3, and 4 if necessary. Now, to fill this table, we must follow the rule. And the rule is y is equals to 2x minus 1. So when we start substituting at any given interval, where we have x, we shall go step by step. Like to find y, we say y is equals to 2x minus 1. But x is equals to -3 here, so we substitute in, it will be y is equals to 2 into x, which is -3, and then -1. This one will give us y is equals to -6 minus 1. Y is equals to -7. So you come and fill here, -7. You move ahead. The rule is y is equals to 2x minus 1. But x is equals to -2. Substituting in, we have y is equals to 2 into -2 minus 1, which is y is equals to 2 times -2 is -4. Then -2, -1 again, we have -5. So the value here is -5. As you go on for 1, we can now do it offhand. For 1, we find that 2 times -1 is -2, -2 minus 1 is -3. If you are very keen, there is a pattern developing here. Like you expect what is supposed to follow, -1. Let's see. When it is 0, 2 times 0 is 0, 0 minus 1 is -1. When it's 1, 2 times 1 is 2, 2 minus 1 is 1. When it's 2, 2 times 2 is 4, minus 1 is 3. And finally, from the trend, we have 5, and we shall have 7. We choose to go mentally and the pattern that we are enjoying here. So we have our table. Therefore, the coordinates we are going to use to plot are going to be, first coordinate is -3, -7. This one is a coordinate. -2, -5 is another coordinate. -1, -3 is another coordinate. 0, -1 is another coordinate. We have the coordinate I'm calling 1, 1. We have 2, 3. And we have 3, 5. We have 4, 7. Now, for a linear equation, we only need 2 points. But for this case today, we want to confirm if all the points we have plotted will lie on the same straight line. So we are going to go into the graph and now decide on what we want. So let us take up a graph book or a graph paper and use it now to construct these points and confirm if the points are going to be exactly linear or they are not going to be linear. So we need to come up with a Cartesian graph, and we should be able to identify the axis where we have the y-axis, we have our x-axis here, and then from this x-axis that we have, we label them. We want the values of y, at least of x, to range from maybe 0. This is 0. We say the 0 is the origin, where the x and y axis intercept. That is the origin. So 1, 2, 3, and 4, minus 1, minus 2, minus 3, minus 4. For y, it is 1, 2, 3, 4, 5, 6. And this is minus 1, minus 2, minus 3, minus 4. Now, the coordinates we have, we don't need all of them. We are going to pick a number and see if they are going to agree. First coordinate is minus 3, minus 3, minus 7. So I'll go on, this is minus 5, minus 6. So minus 7, I don't have it on my Cartesian. So let me do away with this. Let me move on to minus 2, minus 5. Minus 2 is here, minus 5 is here. So this is the point. Minus 1, minus 3, this is 3, minus 1, minus 3, this is the point. 0, minus 1, 0, minus 1 is here. We have 1, 1, the point 1, 1 is here. We have 2, 3, the point 2, 3. We have the point 1, 1. We have to correct this. This one is 0, this is 1. This one is 2, 3, this is 4. So this is the coordinate 1, 1. Then 2, 3 is here. Then we have the coordinates 3, 5. 3, 5 will be here. Now, when you plot these points, we don't know whether there is a linear relationship or not, but we say that if the points are related by a linear relationship, then all these points will lie on the same straight line, or they'll satisfy the equation that we have looked at. So, using your ruler, you join all the points that you have been able to plot. I want to believe that maybe our Cartesian that we have is accurate enough to give us accurate points, but in your graph book, or your graph paper, you should be accurate. They should lie on the same straight line. So let us look at the points we have plotted here. Very good. If you look at that equation, this is a very good straight line. Now, when you draw a line, you don't leave it like that. You go ahead and write the equation of that line. What equation? What was the law connecting these points? You write that law there, and the law is y is equals to 2x minus 1. So it is always necessary to write the equation that connects that line. So when we are looking, have we been able to come up with a straight line? Yes. Are all our points lying on the same straight line? Yes, they are. So we can simply agree and say that when we are plotting, it is very important that the equations we come up with, we must be able to plot, to draw or construct a table. Then identify the coordinates. Then transfer the coordinates onto the graph. Join the points. That you'll be able to know whether it's a curve or it is a straight line. So we have been able to work out this, and that's what we have. Now, we want to look at a question on how we can determine if some points given lie on the same straight line. You see, we had so many points here, 1, 2, 3, 4, 5, 6. Now, is it possible for us to be given a point and then we can tell whether it lies on the same straight line or not? Now, decide if the points 1, 3 and -2, -4 lie on a graph of y is equals to 3x. We can tell if points lie on a straight line or lie on a rule that will be given if those points satisfy the equation. And for us to tell whether the points satisfy the equation, because the equation has got two sides, the right-hand side and the left-hand side, we substitute accordingly. What belongs to the left-hand side and what belongs to the right-hand side. If it will equate itself to the other one and they are equal, we shall say that the point lies on the same straight line. But if it gives us different values of both left and right, then we shall say the two points are not in the same straight line, or a point is not lying on the straight line. So let us look at this. For the first part, y is on the left-hand side, so let us consider left-hand side. Left-hand side we have what? Y. And what is y? Y is equals to coordinate is 1, 3. So x is 1, y is 3. So it is 3. Should be equal to right-hand side. And right-hand side we have 3x. And 3x is 1. So this is 3 into 1, which is equals to 3. So you find that the left-hand side is equals to the right-hand side. Therefore, the points lie on the line y is equals to 3x. So we've confirmed that that point 1, 3 lies on this line, if you plot it on the graph. Let us look at the second one. We have -2, -4. -2, -4 simply means that we look at the left-hand side. Where we have y, we substitute. The equation is y is equals to 3x. What is the value of y in this coordinate here? Y is minus 4. So put minus 4 here. That is on the left-hand side. It's minus 4. Is it the same as the right-hand side, which is 3 into x, and x is minus 4? This one is going to give us minus 12. Is minus 12 the same as minus 4? Sincerely, this one is not. So we have to, it is 2, not 4. So you are finding that this one here is minus 6. X is minus 2. Minus 2 times 3 is minus 6. So we are looking at minus 6 and minus 4. They are not the same. The left-hand side and the right-hand side are not agreeing. So the two, we shall say the second point does not lie on the same straight line. It does not lie on the same straight line. So let us look at other questions on how we are supposed to approach it. Basically on constructing the table and doing our substitution. So, for the rule of y is equals to 2x plus 7, find the y coordinate for these x coordinates. So what we have been given here are the x coordinates. We are supposed to come up with the y coordinates. Those coordinates are the ones which help us to plot the graph. But this time we are not plotting, we are only identifying the coordinates. So here, what will happen here? From the rule, and x is 1 for the first coordinate. To get the y coordinate here, it will be y is equals to 2 into 1 plus 3, which implies that y is equals to 5. So the y coordinate here is 5. The x coordinate is 1. Therefore, what we require here is 1, 5. For the second rule, x is 2, then we shall have y is equals to 2 into 2 plus 3. Y is equals to 2 times 2 is 4 plus 3 is 7. So we are going to have the coordinate here as 2, 7. So the substitution matters so much. When it is 0 and the rule is y is equals to 2x plus 3 and x is equals to 0, substituting in, you find 2 times 0 is 0, 0 plus 3 is 3, so y here is equals to 3, therefore the coordinates is 0, 3. When x is minus 7, then our rule which states that 2x plus 3 is the value of x when x is what? Minus 7. Substituting this one will give us 2 times minus 7, which is minus 14. Minus 14 plus 3 is minus 11. Therefore, the coordinates is minus 7 minus 11. When it is 11, then it means that when x is 11 from the rule that we have, then y will be is 2 multiplied by 11 plus 3. Y is equals to 22 plus 3, which is 25. Therefore, the coordinates we are looking for is 11, 25. And lastly, when it's minus 5, then y is equals to 2 into minus 5 plus 3, which gives us minus 10. Plus 3, which gives us minus 7. Therefore, coordinate required is minus 5, minus 7. So this is when we are carrying out what we call substitution. This is how we substitute to get the coordinates for the other values. Now let us look at a rule which guides us to construct a table. I want us to use the rules to construct and fill the following table. So we have 2 questions. We need to come up with a table. So we shall have a table for each case. Let the table range for the values of x. We want to give a range of values for x. X ranges from -3. That I think is the less than or greater than x, which is less than or equal to 3. The range here is telling us that x ranges from -3 to +3. So we are only interested to have the table with those values. So we shall have the table which ends 3 to 1, 0, -1, -2, -3, x. So to fill the first table, we need to know the values. Given that x is -3, what is y? That's how we go about it. Then you find that this is -3 plus 1, which is -2. Given that x is -2, what is y? Then this is -2 plus 1, which is what? -1. Given that x is -1, -1 plus 1 is 0. Then this one will give us 1, this one will give us a 2, a 3, and a 4. So this is just filling the table, constructing the table given a rule and the range of the x coordinates. So what we have down here are the y coordinates. Right? Let us look at the second equation. Now look here. Find the coordinates of y given that this is minus x plus 4. Now, the rule is y is equals to minus x plus 4, and when x is minus 3, then we shall have y is equals to minus into bracket minus 3. Be sure of what you are doing here, then plus 4. Minus minus gives us a positive, so this is y is equals to 3 plus 4. Is equals to 7. So this part will be 7. Second one will be y is equals to minus 2, which is plus 2 plus 4, which is 6. This one becomes a 6. This one will be a 5, a 4. And then now when we come to the positive side, y will be equal to minus 1 plus 4. This is 3. So that will be the trend. It is very easier for you to study and know the trend when you are looking at linear relationship, because always y will have certain pattern of numbers. And that's how we normally happen to fill the table as we've done. Now, I want us to look at something detailed on this, what we call the x and y intercept. Now, we talk of an intercept. There is a y-intercept. There is also an x-intercept. What do we mean by this one that we are calling intercepts? These intercepts, like when we say the x-intercept, it is the value of x when it's the value of x when y is equals to 0. That is the x-intercept. While the y-intercept is simply the value of y when x is equals to 0. Let me put it clear and take this one down. So we are talking of two intercepts here, the y-intercept and the x-intercept. The y-intercept and the x-intercept. So we are saying that the y-intercept is the y value. It is the y value of the point where x is equals to 0. For the x-intercept, it is the value of the point where y is equals to 0. What am I trying to say here? This is the y-axis, this is the x-axis, and this is the origin. Just to illustrate, if this is our graph, we've plotted the graph of y is equals to whatever it is. Now, when we talk of x-intercept, the y-intercept, the y-intercept is the y value at the point where x is 0. And when you look at this, here, this is our y-intercept, whereby the value of y at the point where x is 0. What is the value of x here? The value of x here is 0. And what is the value of y here? The value of y here is 4. So we are saying here the y-intercept is 4. That's why we say the y-intercept is the value of y at a point where x is equals to 0. That's what the y-intercept stands for. Let us come to the x-intercept. The x-intercept here is the value of x at a point where y is equals to 0. When you look at the point 2 here, this 2 here is our x-intercept. 2 is our x-intercept. If 2 is our x-intercept, then the issue is, how do we get the y? The x-intercept will be found easily because it is the point where y, the value of y is 0. Is it true that the value of y at this point is 0? Yes, because it lies on x-axis and all coordinates of x or of y along the x-axis is 0. The coordinates of y along the x-axis is 0. So the coordinates of y at the point x is equals to 2 is 0. And that is where this line cuts across the y of the x-axis. So we are saying the x-intercept for this case is equals to 2. And that is the value of x at the point where y is 0. Let us come to this graph. If you look at our graph here, can you identify and write down the x-intercept and the y-intercept? Good. You should have identified already. Let us see. From the equation, y is equals to 2x minus what? Minus 1. Let us identify the value of y, at a point where x is what? Is 0. That one we shall call it the y-intercept. When you look at the value, this is the y-axis. Anywhere along this line, y-axis, the value of x is 0. So we are looking at the line we have plotted, the graph we have plotted. Where does it touch the y-axis? That point where it touches the y-axis is what we shall call the y-intercept. And when you look at it very clearly, it is here. It cuts the y-axis at the point where the value of y is -1, but the coordinates for x is 0. Therefore, in our equation here, we say that our y-intercept for y is equals to 2x minus 1 is what? Is -1. That is it true that -1 is the value of y at the point where x is 0, and it lies on the line of this law? Yes, it is true. How about the x-intercept? We look for the value of x at the point where y is 0 and it lies on the line that we have. And if you look at that, it is here. And at this point, this is 1, this is 0. So this is about a half, that is 0.5. So we can say that the x-intercept is 0.5. That is the value of x at a point where y is 0. At the same time, that point we are talking about is on the line. It must lie on the line. You don't just pick any point. It must lie on the line. That is the x-intercept. Now, then the question comes in. How easier can we identify these intercepts? How can we easily find the intercepts? For example, now they are asking us to find the y-intercept and the x-intercept in this rule. Let us start with the y-intercept. Y-intercept we know that if we talk of y-intercept, the coordinates for x is equals to 0. I'll repeat before I start. We talk of y-intercept as the value of y when x is 0. The value of y when x is 0. So you don't struggle. See, just to find this, just know that x must be 0, and we go on substituting. So the y-intercept here will be found if x is what? 0. This implies that y is equals to 4 minus 2 into 0, which is minus 0. So y is equals to 4. Can you see that? This is our y-intercept. How about the x-intercept? For x-intercept, here, for x-intercept, y must be equal to 0. So for the equation here, y is equals to 4 minus 2x. But y is 0, so we say 0 is equals to 4 minus 2x. We have done this. You can go on systematically. So let us add 2x this side, add 2x this side, so that we have 2x is equals to 4. Divide by x by 2 here, you remain with x is equals to, divide by 2, x equals to 2. So the x-intercept is 2. In other words, I'm saying this. We should be able to find the x-intercept. We should be able to find the y-intercept without actually plotting. So one way of finding the x and y-intercept is simply doing by solving the equation with the substitution of the values of x as 0 and y as 0, respectively. If you do not want to substitute, then it can again be shown on a graph directly. Let us use a graph to find the x and the y-intercept. So the previous method, we were able to find the x-intercept. We were able to find the y-intercept without plotting a graph. Now we want to use a graph and see if we can still get the x and the y-intercept. Sketch the graphs of these rules and find the x and y-intercept. And the first one we have this. Now I want you to know that if you are accurate enough for you to work out this issue of linear equations, we only need to have 2 coordinates. 2 points, and you join the points. Because all the rest of the points of linear relationship will lie on the same straight line. Therefore, if you have only 2 points, maybe the third point to confirm your answer, you are done. So let us see. We can give it a range of, let us have a table. So x is, I start with minus 2. Then the value of y will be positive 2. Minus 1, the value of y will be plus 3. And when it is 0, this is 4. Those are just enough for me. I can plot that one here. So minus 2, 2. Minus 1, 3. Then 0, 4. That is enough for us to know what we are drawing. So take your ruler and join the points. We have our line y is equals to x plus 4, right? That is our line. Now, can we look at the line and identify which one is the x-intercept and which one is the y-intercept? This time, no calculation. Just look at the line, see the line where it crosses the y-axis. We have the y-intercept. Where it crosses the x-axis, we have the x-intercept. So, from this graph we have plotted, the y-intercept is equals to what? You see it is crossing at 4, it is 4. And the x-intercept is when it crosses this other one is negative 4. You see? Using a graph you have taken so easy to find the y and the x-intercept by simply plotting. Let us look at the second one and see whether it will be able to give us, as long as it is within the scale that we have. If it goes outside the scale, then we may not be able to identify, but if it's within the scale, we shall get. So let us look at the second one and see if we can also be able to get the intercepts. So we are going to substitute the values. So let's just start when it's minus 2. Then this minus 2 times 2 is minus 4. This is a 0. When it is minus 1, this is minus 2 plus 4, that is a 2. When it is 0, this will be a 4. So we already have a pattern. So minus 2, 0. Minus 1, 2, 0, 4. And so we join the points and see whether I'm taking 3 because the third point helps us to prove that they are in the same straight line. Very good, very good. Yes. Here we are with our graph. I told you when you plot a line, name that line. So we have got several lines, but we are interested in which line? This one, which is y is equals to 2x plus 4. Now, from that line, can you identify the intercepts? The y-intercept is where a point where y, the plotted line crosses the y-axis and it is 4. So you find that y-intercept is equals to 4, and the x-intercept is equals to negative 2. X-intercept is a point where the plotted line crosses the x-axis. So with that, you find that we are able to find the intercepts by 2 methods. One is simply by substitution, and 2 is by plotting. That is how we handle the issues on the rules, tables, and graphs to explore linear relationship. When we come back in our next class, we shall be finding the rule using the table of values. Rules using the table of values. That is it for now. Thank you.